Hi guys, in this video we will discuss the generic tool which we talked about in the presentation. Now this generic tool is just going to illustrate the framework which we discussed. So let's move on to the code and have a look at the main function. First we define the two thread IDs for the sniffer as well as for the injector. Now these two threads will be running concurrently. So for communication between these threads, we decide to use message queues, and hence we initialize the message queue by calling create message queue and storing the identifier for that created message queue in the message queue variable. Then we start both these threads by using the pthread_create API call. Now this takes as input the function to threadify as well as the argument to pass it. In both the case of the sniffer thread as well as for the injector thread, we will be passing the message queue identifier as the argument, because they will use this message queue for communication between themselves. After creation of these two threads, the main function will go ahead and wait for the sniffer as well as the injector threads to exit. This is accomplished by calling pthread_join on both the thread identifiers. Once both the threads have executed and exited, we will clean up by destroying the message queue which we had created. Now let's go up. Currently we just define the sniffer as well as injector thread without anything inside it, because this just is to illustrate the architecture. We'll actually write a little bit of sniffing code and injection code in one of the videos later, where we will be using this framework as is. Now going back here, so this is the place where we describe the IPC mechanism. Now do not get confused when you look at this. Once you have gone through some basics of message queues from the link provided in the web page, this should be very easy to follow. So we create the message which is going to be sent across using the message queue. This contains the long M type which we discussed, that which is mandatory, and then the int data, which is going to be some data which is going to be passed through this queue. Then we define a create message queue function call, which is nothing but a wrapper over the message get. Now message get actually takes a unique key which we generate using a file name and a project ID as input. This key uniquely defines our message queue in the kernel space. Also, to message get we define a permission set as well as an IPC_create flag. Now this permission is basically 0x44, so that we can read write from this queue from the two separate threads. Let's not dive too deep into it. After a message queue primer, you should be able to easily follow this code. The point really is that create message queue returns a identifier for the queue which has been created. The send message wrapper is nothing but the message send API wrapped around, which takes the message queue as input and the message to be sent through that queue. The receive message API is nothing but a wrapper around the message receive function call. The receive message returns a message mallocing it, which means that the caller of receive message is having the responsibility of freeing this memory allocated. Once again, let's not try and get confused with the message queue formats. Go through a simple primer, this should be easy to follow. The destroy message queue is nothing but an API which destroys the message queue which we created by calling message control inside. Now let's look at the APIs before this. I'm sure you're familiar with the raw socket creation read write API. This is the create raw socket API. You've seen this a million times. The bind raw socket to interface API. Once again, follow the sniffer tutorials, and send raw socket. Have a look at the injection tutorials if you cannot follow this. So with this we come to the end of our architecture code. Let's try and summarize what we did. We basically defined the two threads, that is sniffer and injector, and a message queue which would be the communication channel between these two threads. Then we go ahead and initialize the message queue by calling create message queue. Then we initialize both the sniffer thread as well as the injector thread and pass them the message queue ID as the input. Then we simply wait for the sniffer as well as injector threads to exit. After this has happened, we go ahead and clean up by destroying the message queue which we created. So what this provides is simply a framework. I am not going to add any code here. In the subsequent videos I will use this framework and then show you how to write something meaningful in the sniffer thread and the injector thread and work together, so that these two work together. You can try compiling this tool. As you can see, there is a new option of -L because we need to include the pthread library. Without including this library, you will not be able to compile. And there is no undefined reference to pthread create, etc. So in this case, just include the -L pthread library and it should compile fine. In the next video tutorial, we'll basically pass messages between the sniffer thread and the injector thread. Thank you.